Welcome to Natural Language Processing class at Triune Biblical University Global Extension, USA. Today we're diving into the fascinating world of natural language processing, or NLP. This field sits at the intersection of technology and human communication, making it one of the most exciting areas in artificial intelligence. By the end of this session, you'll understand what NLP is, why it matters, and the core tasks it tackles. Let's start by exploring the definition of NLP and its unique position in the broader landscape of intelligent systems. Natural language processing, or NLP, is a specialized branch of artificial intelligence. Its main goal is to enable machines to understand, interpret, generate, and respond to human language. Think of NLP as the bridge that connects computers with the way people naturally communicate, whether through speech or text. This connection is crucial for making technology more intuitive and accessible for everyone. NLP doesn't stand alone. It draws from several fields including computer science, linguistics, artificial intelligence, and cognitive science. Each discipline brings unique insights. Computer science provides algorithms, linguistics offers understanding of language structure, AI delivers learning capabilities, and cognitive science helps model human thought. Together, they form the backbone of NLP, making it a truly interdisciplinary field. Language is at the heart of human interaction. It's how we communicate, share knowledge, and build relationships. For intelligent systems to be truly useful and natural, they must process both spoken and written language. This ability allows AI to understand context, intent, and meaning, making technology feel more human and approachable. Communication is more than just exchanging words. It's about conveying ideas, emotions, and intentions. NLP empowers machines to participate in this process, allowing them to understand and generate language in ways that are meaningful to humans. This is essential for creating AI that can interact naturally and effectively in our daily lives. Language is also a powerful tool for sharing knowledge. Whether it's reading a book, listening to a lecture, or chatting with a friend, language allows us to pass information from one person to another. In the world of AI, NLP enables machines to access, process, and share vast amounts of knowledge, making them valuable partners in learning and discovery. Social interaction is a fundamental part of human life. We use language to build relationships, express feelings, and collaborate with others. For AI to be truly integrated into our social world, it must understand the nuances of language, including tone, context, and cultural references. NLP is the key to making these interactions possible. Language isn't just about words, it's also about symbols and meaning. We use language to represent ideas, make arguments, and solve problems. NLP enables machines to reason through these symbols, helping them understand not just what we say, but what we mean. This is crucial for tasks like answering questions or making decisions. For intelligent systems to interact naturally with humans, they must process both spoken and written language. This means understanding grammar, context, and even the emotions behind words. NLP provides the tools and techniques that make this possible, allowing AI to become more responsive and adaptive to our needs. Now let's take a closer look at the core tasks that NLP tackles. These tasks form the foundation of how machines process and understand language. From classifying text to translating languages, each task plays a unique role in making AI more capable and versatile. Text classification is one of the most fundamental tasks in NLP. It involves sorting text into categories based on its content. For example, spam email filtering uses text classification to separate unwanted messages from important ones. This task helps machines quickly organize and make sense of large volumes of information. Machine translation is another key task in NLP. It allows computers to automatically translate text from one language to another. This technology powers tools like Google Translate, breaking down language barriers and making information accessible to people around the world. Named entity recognition, or NER, is about identifying specific entities in text, such as names of people, organizations, or locations. This helps machines extract important information and understand the context of a conversation or document. NER is widely used in applications like search engines and digital assistants. Speech recognition enables machines to convert spoken language into text. This technology is behind voice assistants like Siri and Alexa, allowing users to interact with devices using natural speech. Speech recognition makes technology more accessible, especially for those who prefer talking over typing. Sentiment analysis is all about understanding emotions in text. It helps machines determine whether a message is positive, negative, or neutral. Businesses use sentiment analysis to gauge customer feedback and improve their products or services based on real opinions. Text generation allows machines to create new text based on input or context. This is the technology behind chatbots and content creation tools. Text generation can be used for writing articles, composing emails, or even generating creative stories, making AI a valuable partner in communication. Practical example of NLP in action is spam email filtering. By analyzing the content of emails, NLP systems can automatically detect and separate spam from legitimate messages. This not only saves time but also protects users from unwanted or harmful content. NLP is widely used to analyze customer feedback. By processing reviews, surveys, and comments, NLP systems can identify trends, common issues, and overall sentiment. This information helps businesses make informed decisions and improve customer satisfaction. Voice assistants like Siri, Alexa, and Google Assistant rely heavily on NLP. They process spoken commands, understand user intent, and generate appropriate responses. This seamless interaction is made possible by combining speech recognition, language understanding, and text generation. Understanding language isn't just about words, it's about context. NLP systems must consider the surrounding words, the speaker's intent, and even cultural factors to accurately interpret meaning. This makes NLP a complex but rewarding field as it brings machines closer to understanding human communication. The ultimate goal of NLP is to enable machines to interact with humans as naturally as possible. This means not only understanding words but also grasping tone, emotion, and intent. As NLP technology advances, we're seeing more human-like interactions in everything from customer service to personal assistance. NLP acts as a bridge between humans and machines. By translating human language into a form that computers can process, NLP makes it possible for us to communicate with technology in our own words. This bridge is essential for creating more intuitive and user-friendly systems. In the early days, machines could only perform simple text processing like searching for keywords or counting words. Today, thanks to advances in NLP, machines can understand context, generate responses, and even hold conversations. This evolution marks a significant leap in AI capabilities. Data is the fuel that powers NLP systems. By training on large datasets of text and speech, machines learn to recognize patterns, understand meaning, and generate appropriate responses. The more data an NLP system has, the better it becomes at understanding and using language. Algorithms are at the core of NLP. They process language data, identify patterns, and make predictions. From simple rule-based systems to advanced machine learning models, algorithms enable machines to handle complex language tasks with increasing accuracy and efficiency. While technology is essential, the human element remains at the heart of NLP. Linguists, computer scientists, and cognitive scientists all contribute to building systems that understand and use language effectively. This collaboration ensures that NLP continues to evolve in ways that benefit society. NLP is all around us, even if we don't always notice it. From autocorrect on your phone to voice search on your smart speaker, NLP powers many of the tools we use every day. Its impact is growing as technology becomes more integrated into our lives. Despite its progress, NLP still faces many challenges. Language is complex, full of ambiguity, slang, and cultural differences. Machines must learn to navigate these challenges to truly understand and generate human language. Ongoing research is focused on making NLP systems more robust and adaptable. The future of NLP is bright. As technology advances, we can expect even more natural and seamless interactions between humans and machines. From real-time translation to personalized assistance, NLP will continue to shape the way we communicate and interact with technology. NLP plays a vital role in making technology accessible to everyone. Speech recognition helps those with disabilities interact with devices, while translation tools break down language barriers. By making communication easier, NLP promotes inclusivity and equal access to information. Businesses use NLP to analyze customer feedback, automate support, and gain insights from data. By understanding language, companies can respond faster, improve products, and deliver better customer experiences. NLP is becoming a key driver of innovation in the business world. In healthcare, NLP helps process medical records, extract important information, and support patient care. By understanding doctors' notes and patient feedback, NLP systems can assist in diagnosis, treatment planning, and research, making healthcare more efficient and effective. NLP is transforming education by enabling personalized learning, automated grading, and intelligent tutoring systems. By understanding student responses and adapting to individual needs, NLP helps create more engaging and effective learning experiences. Entertainment platforms use NLP to recommend content, generate subtitles, and even create scripts. By analyzing user preferences and understanding language, NLP helps deliver more personalized and enjoyable experiences in movies, music, and games. Social media platforms rely on NLP to filter content, detect harmful language, and analyze trends. By processing millions of posts every day, NLP helps keep online communities safe and relevant while also providing insights into public opinion. As NLP systems process more personal data, privacy becomes a major concern. Developers must ensure that language data is handled securely and ethically. Balancing innovation with privacy protection is essential for building trust in NLP technologies. Ethical considerations are crucial in NLP. Issues like bias, fairness, and transparency must be addressed to ensure that NLP systems serve everyone equally. Ongoing research and responsible development are key to making NLP a force for good. NLP supports multilingual communication by enabling translation and understanding across languages. This is vital in our globalized world where people speak hundreds of different languages. NLP helps bridge these gaps and foster international collaboration. NLP isn't just about analysis, it's also about creativity. From generating poetry to composing music lyrics, NLP systems are being used to create new forms of art and expression. This opens up exciting possibilities for collaboration between humans and machines. Personalization is a major trend in technology, and NLP plays a big role. By understanding user preferences and behavior, NLP systems can tailor content, recommendations, and interactions to each individual, making technology more relevant and engaging. Real-time processing is essential for applications like chatbots and virtual assistants. NLP systems must analyze and respond to language instantly, providing users with quick and accurate answers. This requires advanced algorithms and powerful computing resources. NLP is a key tool for making sense of big data. By processing massive amounts of text and speech, NLP systems can extract valuable insights, identify trends, and support decision-making in fields like business, healthcare, and research. Automation is transforming industries, and NLP is at the forefront. By automating tasks like customer support, document analysis, and content moderation, NLP helps organizations save time and resources while improving accuracy and consistency. NLP systems are constantly learning and improving. By analyzing new data and adapting to changing language patterns, they become more accurate and effective over time. This continuous learning is essential for keeping up with the evolving nature of human language. As we wrap up this introduction to NLP, remember that language is at the core of intelligent systems. NLP enables machines to understand, interpret, and generate human language, making technology more accessible and powerful. In the next lecture, we'll explore how machines evolved from simple text processing to the sophisticated conversational AI we see today.
Welcome to our exploration of the history and evolution of natural language processing, or NLP. In this video, we'll journey through the key phases that have shaped how machines understand and generate human language. From the philosophical roots laid by Alan Turing, to the rule-based systems of the early days, and all the way to the neural networks powering today's large language models, you'll gain a clear understanding of the milestones and paradigm shifts that define NLP. Let's begin by setting the stage with the earliest foundations of machine intelligence. The story starts in 1950, when Alan Turing published his groundbreaking paper, Computing Machinery and Intelligence. Turing posed a simple yet profound question: can machines think? He introduced the Turing test, a method for determining if a machine could convincingly imitate human conversation. This philosophical foundation didn't just spark debates, it inspired decades of research into how computers might process and understand language. Turing's ideas laid the groundwork for what would become the field of NLP, influencing generations of scientists and engineers. Turing test is a simple yet powerful idea. Imagine a human judge interacting with both a person and a machine through text. If the judge can't reliably tell which is which, the machine is said to exhibit intelligent behavior. This test became a benchmark for artificial intelligence, and by extension for NLP. It shifted the focus from mere computation to the imitation of human-like conversation, setting a high bar for what machines should achieve in language understanding. Following Turing's vision, early NLP research in the 1950s and 1960s focused on symbolic approaches. Researchers aimed to create systems that could process language using explicit rules and logic. These early efforts were ambitious, seeking to capture the complexity of human language in a set of formal instructions. While progress was slow, these foundational ideas set the stage for the rule-based era that would soon follow. The 1960s through the 1980s marked the rise of rule-based NLP systems. These systems relied on handcrafted linguistic rules to parse and understand language. Grammar-based models and symbolic parsing were at the heart of this approach. Researchers painstakingly encoded the rules of language, hoping to capture its structure and meaning. This era saw the development of some of the earliest chatbots, which, while limited, demonstrated the potential of computers to simulate conversation. Rule-based systems depended heavily on grammar. Linguists and computer scientists worked together to define the syntax and structure of language in a way that computers could process. These systems could analyze sentences, identify parts of speech, and even generate simple responses. However, they were limited by the complexity and variability of natural language, making them brittle and difficult to scale. Symbolic parsing was a core technique in rule-based NLP. It involved breaking down sentences into their grammatical components using predefined rules. This allowed systems to identify subjects, verbs, objects, and other elements of language. While effective for well-formed sentences, symbolic parsing struggled with ambiguity and the nuances of real-world language, highlighting the limitations of purely rule-driven approaches. One of the most famous early chatbots was ELIZA, developed in the 1960s. ELIZA simulated a psychotherapist by using pattern matching and scripted responses. Users could type in statements, and ELIZA would reply with questions or comments that mimicked a therapeutic conversation. While the LIZA didn't truly understand language, it demonstrated how rule-based systems could create the illusion of conversation, captivating both researchers and the public. Despite their early promise, rule-based NLP systems had significant limitations. They were brittle, meaning small changes in input could cause them to fail. These systems lacked real understanding of language and relied on hard-coded rules that were difficult to maintain and expand. As language is inherently flexible and context-dependent, rule-based approaches struggled to handle the diversity and unpredictability of human communication. In the 1990s, researchers recognized the need for more flexible and data-driven approaches. This led to the rise of statistical NLP, which used probability and statistics to model language. Instead of relying solely on rules, these systems learned from large datasets, enabling them to handle ambiguity and variation more effectively. The shift to statistical methods marked a major turning point in the evolution of NLP. Statistical NLP introduced models that could learn patterns from data. Hidden Markov models, HMMs, N-gram models, and Bayesian classifiers became popular tools. These models analyzed large corpora of text to estimate the likelihood of word sequences and grammatical structures. By leveraging statistics, NLP systems could make informed guesses about language, improving tasks like translation and speech recognition. Hidden Markov models, or HMMs, became a cornerstone of statistical NLP. HMMs are probabilistic models that can predict sequences, making them ideal for tasks like part-of-speech tagging and speech recognition. By modeling the likelihood of transitions between states, HMMs enable computers to process language in a more dynamic and flexible way than rule-based systems. N-gram models are another key statistical approach. These models predict the next word in a sequence based on the previous N words. By analyzing large amounts of text, N-gram models can capture common word patterns and improve the accuracy of language tasks like text prediction and machine translation. Their simplicity and effectiveness made them a staple of statistical NLP. Bayesian classifiers brought probabilistic reasoning to NLP. These models use Bayes' theorem to classify text based on the likelihood of certain features. For example, they can determine whether an email is spam by analyzing the frequency of specific words. Bayesian classifiers helped automate tasks that previously required manual rules, making NLP systems more adaptable and scalable. Statistical NLP offered several advantages over rule-based systems. By learning from data, these models could adapt to new language patterns and handle ambiguity more effectively. They improved the performance of applications like machine translation and speech recognition, making NLP more practical for real-world use. The ability to scale with data marked a significant leap forward for the field. One of the most notable successes of statistical NLP was in machine translation. By analyzing bilingual corpora, statistical models could learn how words and phrases in one language corresponded to those in another. This data-driven approach led to significant improvements in translation quality, laying the groundwork for the sophisticated translation systems we use today. Statistical models also revolutionized speech recognition. By modeling the probabilities of sound sequences and their corresponding words, these systems could transcribe spoken language with greater accuracy. This breakthrough made voice-controlled applications and virtual assistants possible, bringing NLP into everyday life for millions of users. Despite their strengths, statistical models had their own limitations. They often required vast amounts of labeled data and struggled with rare or unseen words. Additionally, these models typically treated language as a sequence of independent events, missing deeper context and meaning. As a result, researchers began searching for new approaches that could capture the richness of human language. The next major shift in NLP came with the advent of neural networks. Inspired by the human brain, neural models could learn complex patterns and representations from data. This approach allowed systems to capture context, semantics, and even subtle nuances in language, paving the way for more sophisticated NLP applications. Word embeddings are a foundational concept in neural NLP. These are mathematical representations of words in a continuous vector space, where similar words are located close to each other. Word embeddings capture semantic relationships, enabling models to understand meaning and context. This innovation made it possible for computers to process language in a more human-like way. Recurrent neural networks, or RNNs, brought a new level of sophistication to NLP. Unlike previous models, RNNs could process sequences of data, making them ideal for language tasks where context matters. By maintaining a memory of previous words, RNNs improved the modeling of sentences and paragraphs, enabling more coherent text generation and understanding. The introduction of transformers marked a revolution in NLP. Unlike RNNs, transformers use attention mechanisms to process entire sequences at once, capturing long-range dependencies and context. This architecture enabled breakthroughs in tasks like translation, summarization, and question answering, setting new benchmarks for performance and scalability. Organizations like OpenAI pushed the boundaries of NLP with large language models. These models, trained on massive datasets, can generate coherent text, answer questions, and engage in meaningful dialogue. The scale and capability of these models have transformed how we interact with technology, making NLP an integral part of modern applications. Today, NLP powers a wide range of applications, from virtual assistants and chatbots to translation services and content generation tools. The combination of neural networks and large datasets has enabled machines to understand and produce language with remarkable fluency, making NLP technology accessible to millions around the world. Modern dialogue systems leverage neural models to engage users in natural conversations. These systems can answer questions, provide recommendations, and even exhibit personality traits. By understanding context and intent, dialogue systems have become essential tools in customer service, education, and entertainment. Machine translation has reached new heights with neural models. Systems like Google Translate use deep learning to provide accurate and fluent translations across dozens of languages. These advances have broken down language barriers, enabling global communication and collaboration like never before. Large language models excel at generating text that is coherent, contextually relevant, and even creative. From writing articles and stories to composing emails and code, these models have demonstrated an impressive ability to mimic human writing styles and adapt to various tasks. NLP is now embedded in many aspects of daily life. Whether you're using a voice assistant, searching the web, or receiving automated customer support, NLP technologies are working behind the scenes to interpret and respond to your language. This widespread adoption highlights the practical impact of decades of research and innovation. Let's take a moment to compare the three major approaches in NLP: rule-based, statistical, and neural. Each has its strengths and weaknesses. Rule-based systems offer transparency but lack flexibility. Statistical models adapt to data but may miss deeper meaning. Neural models capture context and semantics but require significant computational resources. Understanding these differences helps us appreciate the evolution of NLP. Rule-based systems rely on explicit instructions, making them easy to understand but hard to scale. Statistical models, on the other hand, learn from data and can handle variability, but they may struggle with rare cases and lack interpretability. The transition from rules to statistics marked a move toward more robust and adaptable NLP systems. While statistical models improved flexibility, they often missed the deeper context of language. Neural models addressed this by learning rich representations and capturing long-range dependencies. This shift enabled NLP systems to understand meaning, context, and even subtle nuances, making them far more effective for complex language tasks. Neural models excel at capturing context, semantics, and relationships between words. They can process entire documents, generate fluent text, and adapt to a wide range of tasks. Their ability to learn from massive datasets has made them the backbone of modern NLP applications, from chatbots to translation engines. Despite their power, neural models come with challenges. They require large amounts of data and computational resources, making them expensive to train and deploy. Additionally, their complexity can make them difficult to interpret, raising questions about transparency and fairness in NLP systems. Data has played a central role in the evolution of NLP. From handcrafted rules to statistical learning and neural networks, the availability and quality of data have driven progress. Today's models are only as good as the data they're trained on, making data collection and curation a critical part of NLP research. Throughout its history, NLP has achieved several key milestones. From the Turing test and ELIZA to the first statistical translation systems and the rise of transformers, each breakthrough has expanded the possibilities of what machines can do with language. These milestones mark the progress of a field that continues to evolve rapidly. Organizations like OpenAI have played a pivotal role in advancing NLP. By developing large-scale language models and making them accessible to the public, they have accelerated research and innovation. These models are now used in a variety of applications, from creative writing to technical support, showcasing the versatility of modern NLP. NLP is not just an academic pursuit, it's a driving force in industry as well. Companies use NLP to analyze customer feedback, automate support, and personalize user experiences. The collaboration between academia and industry has fueled rapid advancements, making NLP a cornerstone of modern technology. As NLP systems become more powerful, ethical considerations have come to the forefront. Issues like bias, privacy, and transparency must be addressed to ensure that NLP technologies are used responsibly. Researchers and practitioners are working to develop guidelines and tools that promote fairness and accountability in NLP. Looking ahead, NLP continues to evolve at a rapid pace. Researchers are exploring new architectures, training methods, and applications. The integration of multimodal data, such as images and audio, promises to make NLP systems even more versatile and intelligent. The future holds exciting possibilities for language technology. Multimodal NLP combines language with other forms of data, such as images and audio. By integrating multiple sources of information, these systems can achieve a deeper understanding of context and meaning. This approach is opening up new frontiers in areas like visual question answering and multimedia content analysis. NLP is enabling new forms of collaboration between humans and machines. From co-writing documents to assisting with research, AI-powered language tools are becoming valuable partners in creative and analytical tasks. This synergy is reshaping how we work and communicate. Modern NLP systems can personalize interactions based on user preferences and context. Whether it's tailoring recommendations, adapting tone, or providing relevant information, personalization is enhancing user experiences across platforms and services. NLP is making technology more accessible for people with disabilities. Speech-to-text, text-to-speech, and language simplification tools are helping users communicate and access information more easily. These advances are promoting inclusivity and breaking down barriers to technology. NLP models are increasingly capable of continuous learning, adapting to new data and evolving language use. This ability to learn and update over time ensures that NLP systems remain relevant and effective in a rapidly changing world. In summary, the history and evolution of NLP is a story of innovation, adaptation, and discovery. From Turing's early ideas to today's neural models, each phase has contributed to our understanding of language and intelligence. As NLP continues to advance, it promises to transform how we communicate, learn, and interact with technology. Thank you for joining this journey through the fascinating world of NLP.
Welcome. Today we're diving into the fascinating world of natural language processing, or NLP. Our focus will be on three major paradigms that have shaped the field: rule-based, statistical, and neural approaches. By the end of this session, you'll be able to compare these paradigms, understand their strengths and weaknesses, and see how they connect to real-world systems. Let's start by setting the stage for why these paradigms matter and how they've evolved over time to tackle the complexities of human language. Pairing NLP paradigms is crucial because each approach offers unique solutions to language processing challenges. Understanding their differences helps us choose the right tool for specific tasks, whether it's building a chatbot, translating text, or analyzing sentiment. As technology advances, knowing the strengths and limitations of each paradigm ensures we can design systems that are both effective and efficient. Let's begin by exploring the earliest approach: rule-based NLP. Rule-based NLP systems were the pioneers in language processing. These systems rely on handcrafted grammar rules and dictionaries to parse and understand text. Developers manually encode linguistic knowledge, specifying how sentences should be structured and interpreted. The outputs are deterministic, meaning the same input always produces the same result. This approach laid the groundwork for more advanced methods and is still used in certain applications today. One of the main strengths of rule-based NLP is its transparency. Because the rules are explicitly defined, it's easy to trace how a system arrives at its conclusions. This makes rule-based systems highly explainable, which is valuable in settings where understanding the decision process is important. For example, in legal or medical applications, being able to justify a system's output is crucial. Despite their strengths, rule-based NLP systems face significant challenges. They struggle to scale because every new language feature or exception requires manual rule creation. Additionally, human language is full of ambiguity and nuance, making it difficult to capture all possible variations with rules alone. As a result, rule-based systems often fall short when dealing with complex or ambiguous text. To overcome the limitations of rule-based systems, researchers turn to statistical methods. Statistical NLP leverages probability and data-driven learning to analyze language. Instead of relying on handcrafted rules, these systems learn patterns from large datasets, making them more adaptable to real-world language use. Let's take a closer look at how statistical NLP works. Statistical NLP models use probability to make decisions about language. They analyze large amounts of text data to identify patterns and relationships between words and phrases. Feature engineering is a key part of this process, where experts select relevant characteristics from the data to improve model performance. This approach marked a significant shift from rigid rules to flexible, data-driven solutions. Statistical NLP systems are highly adaptable. By learning from real-world data, they can handle a wide variety of language inputs and improve over time as more data becomes available. This adaptability leads to better performance compared to rule-based systems, especially in tasks like speech recognition and machine translation, where language use is diverse and constantly evolving. However, statistical NLP isn't without its drawbacks. These models often struggle with understanding the deeper context of language as they rely on surface-level patterns. Their performance is heavily dependent on the quality and quantity of training data. Without enough data or with biased data, statistical models can produce unreliable results. Next major leap in NLP came with the advent of neural networks and deep learning. Neural NLP systems use complex architectures to automatically learn features from data, capturing intricate patterns and contexts that earlier models missed. This shift has led to remarkable improvements in language understanding and generation. Neural NLP models, such as those based on deep learning and transformers, have revolutionized the field. These models automatically learn relevant features from massive datasets, eliminating the need for manual feature engineering. They are context-aware, meaning they can understand the meaning of words based on their surrounding text, which is crucial for tasks like translation and summarization. Neural NLP systems offer several key advantages. They achieve high performance on a wide range of language tasks, from question answering to text generation. Their ability to understand context allows them to produce more accurate and natural outputs. Additionally, neural models are highly scalable, making them suitable for large-scale applications like search engines and virtual assistants. Despite their impressive capabilities, neural NLP models have some notable weaknesses. They require vast amounts of data to train effectively, which can be a barrier for smaller organizations. Training and running these models also demand significant computational resources. Furthermore, neural models often lack explainability, making it difficult to understand how they arrive at specific decisions. Now that we've explored each paradigm individually, let's compare them side by side. Rule-based systems offer transparency but struggle with scalability. Statistical models adapt to data but may miss deeper context. Neural models excel in performance and context but require significant resources. Each approach has its place, and the best choice depends on the specific application and constraints. Transparency is a key consideration when choosing an NLP paradigm. Rule-based systems are the most transparent, as every decision can be traced back to a specific rule. Statistical and neural models, on the other hand, operate more like black boxes, making it harder to explain their outputs. This trade-off is important in fields where accountability is required. Scalability and adaptability are strengths of statistical and neural NLP systems. Rule-based systems require manual updates for every new language feature, making them hard to scale. In contrast, statistical and neural models can adapt to new data and languages with less manual intervention, making them ideal for large-scale, dynamic applications. Understanding context is where neural NLP truly shines. While rule-based and statistical models can handle basic patterns, they often miss the subtle meanings that come from context. Neural models, especially those using transformers, can capture these nuances, leading to more accurate and natural language processing. Resource requirements vary greatly between paradigms. Rule-based systems need expert knowledge but little computational power. Statistical models require data and moderate computing resources. Neural models, however, demand both large datasets and significant computational infrastructure, which can be a limiting factor for some organizations. Explainability is essential in many real-world applications. Rule-based systems are easy to audit, making them suitable for regulated industries. Statistical and neural models, while powerful, often require additional tools or techniques to interpret their decisions. This can be a challenge when transparency is a priority. Let's connect these paradigms to practical systems you might encounter. Rule-based NLP is often used in grammar checkers and simple chatbots. Statistical NLP powers spam filters and early machine translation systems. Neural NLP is behind today's advanced virtual assistants, real-time translation, and sophisticated text generation tools. Classic example of rule-based NLP is a grammar checker. These systems use predefined rules to identify errors in text, such as subject-verb agreement or punctuation mistakes. Because the rules are explicit, users can see exactly why a correction was made, making these tools both reliable and transparent. Spam filters are a great example of statistical NLP in action. These systems analyze large volumes of email data to identify patterns associated with spam messages. By learning from data, they can adapt to new types of spam and improve their accuracy over time, offering a flexible solution to a constantly evolving problem. Neural NLP powers many of the advanced language technologies we use today. Virtual assistants like Siri and Alexa rely on deep learning to understand and respond to complex queries. Real-time translation apps use neural models to provide accurate translations, even for idiomatic expressions. These applications showcase the power and versatility of neural NLP. Many modern NLP systems combine elements from multiple paradigms. For example, a chatbot might use rule-based logic for simple queries and neural models for more complex conversations. This hybrid approach allows developers to balance transparency, adaptability, and performance, leveraging the strengths of each paradigm. Selecting the right NLP paradigm depends on your specific needs. If transparency and explainability are top priorities, rule-based systems may be best. For adaptability and improved performance, statistical models are a strong choice. If you need high performance and deep context understanding, neural models are the way to go, provided you have the necessary resources. Evolution from rule-based to statistical to neural NLP reflects the growing complexity of language processing tasks. Each new paradigm builds on the strengths and addresses the weaknesses of its predecessors. This ongoing evolution is driven by advances in computing power, data availability, and our understanding of language. NLP paradigms have had a profound impact on industries ranging from healthcare to finance. Automated document processing, intelligent customer support, and real-time translation are just a few examples of how these technologies are transforming business operations and improving user experiences. Despite significant progress, NLP still faces many challenges. Language is inherently ambiguous and context-dependent, making it difficult for even the most advanced models to fully understand meaning. Bias in training data, computational costs, and the need for explainability remain ongoing concerns in the field. Looking ahead, the future of NLP will likely involve even deeper integration of neural models with other approaches. Researchers are exploring ways to make neural systems more explainable and less data-hungry. Advances in transfer learning and unsupervised learning are opening new possibilities for language understanding. Transfer learning has become a game-changer in neural NLP. By pre-training models on large datasets and fine-tuning them for specific tasks, we can achieve high performance with less data and computation. This approach is making advanced NLP accessible to a wider range of applications and organizations. Unsupervised learning is another exciting area in NLP. These methods allow models to learn from unlabeled data, reducing the need for expensive annotation. Techniques like word embeddings and self-supervised learning are helping models capture deeper language patterns and relationships. Explainable AI is becoming increasingly important in NLP. Researchers are developing new methods to interpret neural models, such as attention visualization and feature attribution. These tools help users understand how models make decisions, building trust and enabling safer deployment in sensitive domains. Ethics play a crucial role in NLP development. Issues like bias, fairness, and privacy must be addressed to ensure that language technologies benefit everyone. Ongoing research aims to identify and mitigate biases in training data and model outputs, promoting more equitable and responsible AI systems. In healthcare, NLP is used to extract valuable information from medical records, assist in diagnosis, and support patient care. Rule-based systems ensure transparency, while neural models enable advanced tasks like medical image captioning and automated report generation. The combination of paradigms helps balance accuracy and explainability. Finance industry leverages NLP for tasks like sentiment analysis, fraud detection, and automated trading. Statistical models analyze market trends, while neural models process vast amounts of financial news and social media data. These technologies help organizations make informed decisions quickly and accurately. Customer support has been transformed by NLP technologies. Chatbots and virtual assistants handle routine queries using a mix of rule-based and neural approaches. This allows companies to provide fast, consistent service while freeing up human agents for more complex issues. In education, NLP is used for automated essay scoring, personalized learning, and language tutoring. Rule-based systems provide clear feedback while neural models adapt to individual student needs. These tools help educators deliver more effective and tailored instruction. Social media platforms use NLP to filter harmful content, detect fake news, and analyze public sentiment. Neural models process massive streams of data in real time, helping platforms maintain safe and engaging environments for users worldwide. Entertainment platforms use NLP for content recommendation, automatic subtitling, and interactive storytelling. Neural models analyze user preferences and generate personalized experiences, making entertainment more engaging and accessible. Legal professionals use NLP to review contracts, extract key information, and predict case outcomes. Rule-based systems ensure compliance, while neural models handle large volumes of legal documents efficiently. This combination streamlines legal workflows and enhances decision-making. E-commerce platforms use NLP for product search, recommendation, and customer feedback analysis. Neural models understand user queries and preferences, improving the shopping experience and driving sales. Statistical models help identify trends and optimize inventory management. Governments use NLP to analyze public opinion, automate document processing, and improve citizen services. Rule-based systems ensure transparency, while neural models handle large-scale data analysis. These technologies help governments respond more effectively to public needs. Scientists use NLP to mine research papers, extract insights, and accelerate discoveries. Neural models process vast amounts of scientific literature, helping researchers stay up to date and identify new trends. Statistical models assist in organizing and summarizing complex information. To sum up, rule-based, statistical, and neural NLP paradigms each offer unique advantages and face distinct challenges. Understanding these differences is key to building effective language technologies. As the field continues to evolve, combining the best aspects of each paradigm will drive further innovation and impact. Future of NLP is bright, with ongoing research pushing the boundaries of what's possible. As we continue to develop more powerful, adaptable, and explainable systems, NLP will play an even greater role in shaping how we interact with technology and each other. Stay curious and keep exploring the world of language technology.
Welcome to our exploration of NLP applications and human-robot interaction. In this session, we'll uncover how natural language processing, or NLP, is transforming the way humans and machines communicate. From everyday chatbots to advanced robotics, NLP is at the heart of intuitive, seamless interactions. We'll start by looking at real-world applications, then dive into how NLP powers robotics, and finally, we'll reflect on whether machines can truly understand language. Let's begin by understanding the broad landscape of NLP in our daily lives. One of the most familiar NLP applications is the chatbot. These digital assistants are everywhere, from answering your questions on e-commerce sites to helping you book appointments. Chatbots automate customer service, providing instant responses and freeing up human agents for more complex tasks. They use NLP to interpret your queries, understand intent, and generate relevant replies. Whether you're chatting with a virtual assistant on your phone or getting help from a website support bot, NLP is working behind the scenes to make the conversation feel natural and efficient. Virtual assistants like Siri, Alexa, and Google Assistant have become household names. These systems rely on NLP to understand spoken commands, answer questions, and even control smart home devices. By processing natural language, they can set reminders, play music, or provide weather updates, all through simple voice interactions. The sophistication of these assistants is a testament to the power of NLP, making technology more accessible and user-friendly for people of all ages. Imagine traveling abroad and instantly translating a menu or conversation. Machine translation systems, such as Google Translate, use NLP to break down language barriers. These tools analyze text or speech in one language and generate accurate translations in another, often in real time. This capability is invaluable for global communication, business, and travel, allowing people to connect and collaborate across cultures with ease. Speech-to-text technology is another remarkable NLP application. It converts spoken language into written text, making it easier to transcribe meetings, dictate messages, or assist those with hearing impairments. Voice assistants and transcription services rely on this technology to accurately capture and process human speech. The result is a more inclusive and efficient way to interact with digital devices, bridging the gap between spoken and written communication. Sentiment analysis is a powerful tool for understanding public opinion. By analyzing social media posts, product reviews, or political commentary, NLP systems can detect emotions and attitudes expressed in text. Companies use sentiment analysis to monitor their brand reputation, while political analysts gauge public sentiment on key issues. This application helps organizations respond proactively to trends and feedback, making data-driven decisions based on real human emotions. Brands today rely on NLP to keep a pulse on their public image. By scanning millions of online mentions, NLP-powered tools can identify positive or negative trends, flagging potential PR issues before they escalate. This real-time monitoring allows companies to engage with customers, address concerns, and celebrate positive feedback. The ability to understand and react to public sentiment is crucial in today's fast-paced digital landscape. NLP is also used to analyze political opinions expressed online. By processing large volumes of tweets, posts, and articles, these systems can identify public attitudes toward policies, candidates, or events. This information helps political strategists, journalists, and researchers understand the mood of the electorate and predict trends. With NLP, the vast world of online discourse becomes a valuable resource for insight and analysis. Now let's shift our focus to robotics. NLP plays a crucial role in enabling robots to understand and respond to human language. Whether it's a robot assistant in a hospital or a social robot in a public space, NLP allows these machines to interpret voice commands, hold conversations, and perform tasks based on spoken instructions. This capability is essential for making robots more intuitive and user-friendly. Voice command interpretation is at the core of human-robot interaction. When you tell a robot to perform a task, NLP systems process your words, detect your intent, and translate it into actionable instructions. For example, saying "bring me water" prompts the robot to understand the request, plan a route, and execute the task. This seamless process relies on advanced language models and real-time processing. Conversational robots are designed to engage in natural, human-like dialogue. These robots use NLP to understand context, manage turn-taking, and respond appropriately to questions or comments. In customer service, education, or entertainment, conversational robots create more engaging and interactive experiences. Their ability to hold meaningful conversations is a testament to the progress in NLP technology. In healthcare, assistive robots equipped with NLP can interact with patients, provide reminders for medication, or offer companionship. These robots are especially valuable for elderly or disabled individuals, supporting independence and improving quality of life. By understanding and responding to spoken requests, healthcare robots make care more accessible and personalized. Social robots are designed to interact with people in public spaces, schools, or homes. They use NLP to recognize speech, interpret emotions, and respond in socially appropriate ways. These robots can greet visitors, answer questions, or even participate in group activities. Their ability to understand and adapt to social cues makes them valuable companions and assistants in a variety of settings. The integration of NLP and robotics follows a clear process. Speech recognition captures the user's words, NLP processing interprets the meaning, intent detection identifies the user's goal, and the robot takes action. This pipeline ensures that robots can respond accurately and efficiently to human instructions, making interactions smoother and more effective. Let's look at a practical example. When you say, "bring me water," the robot's NLP system detects your intent, plans the best route, and carries out the task. This end-to-end process demonstrates how language understanding and robotics work together to deliver real-world solutions. Such examples highlight the importance of NLP in making robots truly helpful and responsive. NLP is essential for creating intuitive communication between humans and robots. By bridging the gap between spoken language and machine understanding, NLP allows robots to respond naturally and appropriately. This makes technology more approachable, especially for those who may not be tech-savvy, and opens up new possibilities for collaboration between people and machines. Now let's turn to a thought-provoking question. Can machines truly understand language? This question invites us to reflect on the nature of machine intelligence and the limits of current technology. As we consider this, we'll explore the differences between pattern recognition and genuine understanding, and what it means for a machine to know language. Machines excel at recognizing patterns in data. NLP systems can identify recurring phrases, structures, and relationships within language. However, does this mean they truly understand what is being said? The distinction between recognizing patterns and grasping meaning is at the heart of the debate about machine language understanding. Another key issue is the difference between syntax and meaning. Machines can analyze the structure of sentences, syntax, very effectively, but understanding the deeper meaning, or semantics, is much more challenging. This raises questions about whether machines can ever move beyond surface-level analysis to true comprehension. Human understanding of language is deeply connected to consciousness and intentionality. We use language to express thoughts, feelings, and intentions. Machines, on the other hand, process language without awareness or purpose. This fundamental difference shapes the ongoing debate about the limits of artificial intelligence in language understanding. Alan Turing, a pioneer in computer science, proposed the imitation game, now known as the Turing test, to evaluate a machine's ability to exhibit intelligent behavior. If a machine can convincingly imitate human conversation, does it truly understand language, or is it simply mimicking patterns? Turing's argument remains central to discussions about machine intelligence and language. Recent advances by organizations like OpenAI have pushed the boundaries of NLP. Large language models can generate human-like text, answer questions, and even create stories. While these systems are impressive, they still rely on statistical patterns rather than true understanding. The progress is remarkable, but the debate about machine comprehension continues. As we reflect on these questions, it's important to recognize both the achievements and limitations of current NLP systems. Machines can process vast amounts of language data, identify trends, and assist in countless applications. However, the leap from processing to understanding remains a significant challenge for researchers and engineers. NLP is already shaping our daily experiences, from the way we interact with our devices to how we access information. Whether it's through voice assistants, chatbots, or translation tools, NLP is making technology more responsive and personalized. As these systems continue to evolve, their influence on society will only grow. Despite its successes, NLP faces significant challenges. Ambiguity, cultural differences, and context can make language difficult for machines to interpret. Researchers are working to improve models so they can better handle these complexities, making NLP systems more robust and reliable. With the widespread use of NLP, ethical considerations become increasingly important. Issues like privacy, bias, and transparency must be addressed to ensure that NLP systems are used responsibly. Developers and organizations must work together to create fair and trustworthy language technologies. Looking ahead, the future of NLP and robotics is full of promise. As language models become more advanced, robots will be able to understand and respond to increasingly complex instructions. This will open up new possibilities for collaboration, automation, and assistance in a wide range of fields. Collaborative robots, or cobots, are designed to work alongside humans in shared environments. With NLP, these robots can understand verbal instructions, ask clarifying questions, and adapt to changing tasks. This partnership between humans and robots is transforming industries like manufacturing, healthcare, and logistics. NLP enables robots and digital assistants to personalize interactions based on user preferences and history. By remembering past conversations and adapting responses, these systems create more meaningful and satisfying experiences. Personalization is key to building trust and engagement with technology. Modern NLP systems are moving beyond text and speech to include multimodal interaction. Robots can now interpret gestures, facial expressions, and even environmental cues, combining these with language input for a richer understanding. This holistic approach makes human-robot interaction more natural and effective. Robots equipped with NLP can learn from their interactions with humans. By analyzing feedback and adapting their behavior, these systems become more effective over time. Continuous learning is essential for creating robots that can handle new situations and meet evolving user needs. NLP-powered robots and systems are making technology more accessible for people with disabilities. Voice-controlled devices, speech-to-text tools, and conversational agents help break down barriers, enabling greater independence and participation in society. In education, NLP is being used to create intelligent tutoring systems, automated grading tools, and interactive learning platforms. These technologies can provide personalized feedback, answer student questions, and support teachers in delivering effective instruction. Customer service is being revolutionized by NLP. Automated chatbots and virtual agents can handle routine inquiries, resolve issues, and escalate complex cases to human representatives. This improves efficiency, reduces wait times, and enhances customer satisfaction. Healthcare providers are using NLP to streamline communication, manage patient records, and support diagnosis. Voice-enabled systems allow doctors to dictate notes, while chatbots assist patients with scheduling and information. This leads to better care and more efficient workflows. NLP is also being used to provide mental health support. Chatbots and virtual counselors can offer guidance, monitor mood, and connect users with resources. While not a replacement for professional care, these tools make support more accessible and immediate. Entertainment platforms use NLP to recommend content, generate subtitles, and even create interactive stories. By understanding user preferences and language, these systems deliver personalized and engaging experiences. Financial institutions use NLP to analyze market sentiment, automate customer service, and detect fraud. By processing news, reports, and customer interactions, NLP systems help organizations make informed decisions and manage risk. Legal professionals are leveraging NLP to review contracts, analyze case law, and predict outcomes. Automated document analysis saves time and reduces errors, allowing lawyers to focus on strategy and client service. Marketers use NLP to analyze customer feedback, track trends, and create targeted campaigns. By understanding what customers are saying, companies can tailor their messaging and improve engagement. NLP is being applied to address social issues, such as detecting hate speech, monitoring misinformation, and supporting disaster response. These applications help create safer and more informed communities. Researchers use NLP to analyze scientific literature, extract insights, and accelerate discovery. Automated tools can process thousands of papers, identify trends, and suggest new directions for investigation. Smart home devices use NLP to interpret voice commands, control appliances, and automate routines. This makes daily life more convenient and efficient, allowing users to manage their environment with simple spoken instructions. Transportation systems are integrating NLP for navigation, customer service, and safety alerts. Voice-enabled systems help drivers get directions, book rides, and receive real-time updates, making travel smoother and safer. In summary, NLP is revolutionizing the way we interact with technology, from chatbots and virtual assistants to advanced robotics. While machines have made great strides in processing language, the question of true understanding remains open. As we continue to innovate, it's important to balance technological progress with ethical considerations and a focus on human needs. Thank you for joining this journey into NLP applications and human-robot interaction.